Right, this video is about this vice that I bought. First impressions, it's a good one. It's got a 360 degree scale all the way around. Surface finish could be a little bit, well, surface paint finish could be a little bit better up. There's sort of flaky paint that's come off it. That threw me out a little bit. They're M12 nuts and M12 bolts, but an M12, a spanner for an M12 nut is 19mm. You need an 18mm spanner for them. They're obviously my own M10, so they're 17mm. That, it's got an indent there. I can't remember what it's called now. Supposed to engage with this, but it doesn't very well. It's still sloppy, so the fit on that's not very good. Bearing in mind the price. The price is only 150. It's not like some ridiculous 600 to 1,000 and upwards. It has, first impression is it has got jaw lift. I was expecting that anyway because the way that the screw is quite far down, and it's not a pull down type vice. It's got a dovetail. It's a dovetail design, which does a good job of keeping the jaws very, very stiff. And it's adjustable, obviously. And it's got a nice smooth action to it. If I clean the jaws off, the jaws meet nice. I forgot to test that on the test bed to see if they're parallel or not, to see if they're actually level, but they're up, it feels it. So if you're making parallels, that'd be a good project to make. You drill holes, stick dowel pins in, or gauge pins, if they were close enough together. You drop it in, mill the top, then you'd rotate it round the other way around, mill the top, and then you'll know that that is then parallel, or as parallel as it can be without being ground anyway. But yeah, first impressions, it's alright. I've done a little bit of testing and that's going to be in the video as well. Something I forgot to mention, there's no inserts, there's no bronze or steel inserts or whatever. That's screwed directly into the actual jaw itself. It's one solid piece. It's not like the jaws don't bolt down onto another part. So you've got to be careful you don't damage that, otherwise you throw it away. You can't make another insert for it. Well, in fact, if you really wanted to, you could make new jaws for it. But you've got to be careful because most vices, they have slots down the side where you can blow out crap or brush it out. But this, it doesn't have any slots. So any swath that lands down there, it gets trapped in there. So you get too much in there, you can see how far the jaw comes forward at the bottom and just there. So if you get too much in there, you're not going to be able to close it up. If you get real hard, like if you're using carbide tooling, or I don't know, CBN tooling, you're doing little minute machining on very hard or HSS parts, you don't want any HSS getting into these screw threads, because obviously when you tighten it up, if it gets dragged into the actual nut itself, to bind up and damage the thread itself. You can't obviously blow it out or brush it out. You'd have to get a vacuum and vacuum it all out, or take the vice off the base, clean it out and put it back on. That's the only downside to it. There's no channels or anything where you can blow any swath out. Right, we'll start on the base. First of all, it doesn't look like it's ground. That's been turned on a lathe. You can see the radial tool marks on it. So that's been turned on a lathe, so they would have ground the bottom because the bottom's nice and smooth. And then they would have bolted it to a face plate or some kind of jig and faced the top with an actual lathe. So that's not a ground consistency. So testing it with a tester, with an indicator, the needle moves a little bit as you go over the oil troughs that's been left behind. That is a nice, very nice tight slip fit, because I had trouble getting out to actually bolt this down to the mill bed to lift the vice off it. So that's a very nice fit, which is good. The bolts, the nuts should I say, to bolt the thingamajig, the vice, to the base, these are M12. These are M12 bolts. Just bolts, standard off the shelf bolts. Look like high tensile. They look like high tensile. These nuts are M12, so these should be 19mm across the flats, but they're not. They're 18mm. That's an 18mm spanner. That's upside down. That's 18. It fits nice and snug in the 18mm spanner. So they've saved us money. Because if they'd have used 19mm hex bars, that would have cost more money. So I thought, I know what we'll do. We'll make them out of 18mm hex bar. That way it'll cut the cost for us, and we'll translate that onto the cost of the price of the vice. So we'll knock the price of the vice down a little bit. But it means that you've got to then go out and buy an 18mm flipping spanner. Because M10 bolts, as you know, uses a 17mm spanner. M12 uses 19, but these are 18. But anyway, that's a little soapbox gripe over and done with. I'll roughly test this. You can't test it that accurate the way that I'm going to do it, because at the end of the day, this is not a proper surface plate, it's just granite with a top off cut. I've got to pull this indicator up and then angle it down. So if you imagine it's like testing with a needle like that, it should be like that. It should be like that, but instead it's like that. And the reason why I've got it down like this is so you can see the dial. So I'll zoom in, I'll get this more stable. I've now put these damn bolts in, which is a bit stupid. So I'll zoom in, I'll set it up. Now this obviously would have been bolted to something before the face was turned. With this not being bolted, it's under the mercy of the actual flatness of the granite worktop, and also the flex in the cast iron. Hopefully, if that was bolted, if I could bolt this down and then rotate that somehow around the part to give a different reading than unbolted. So that's at 40 at the moment, 39. Oh, it's dropping off a little bit. And if that comes back to 39, which it looks like it is doing slowly, that means about a quarter of it. Right, a quarter of that circumference just zoom out. That section there looks like it's one, two. Right, this base, it looks like that quarter there, that quarter of the circumference looks to be about 0.08mm high, compared to the rest of it for some reason. Now with that quarter, or maybe a third, something like that being high, maybe there's flex in the cast iron. And the reason why is when you bolt these down, maybe when I bolt that down it's going to pull that quarter down. I mean, it's only 0.08 of a millimetre, so I can hope basically that when I bolt that down, I've got no dye or anything. I mean, this old Tony tested a vice and it got some blue like paste, I can't remember what it called it now. He just wiped it all over the surface plate and then just ran the part over it, turned it upside down. You can see where the actual contact is of that base to the dye, and any section of it that hasn't got dye on it hasn't been in contact to the plate, so it's high, so when you bolt it, that section is going to pull down. And I think more than likely in that corner underneath there'd be a light patch, but I haven't got any of that dye. So anyway, that's that section. Right, this is now the base of the vice itself. That is quite wild. The good thing is that section there isn't in contact with the top of the vice, but it is with the mill bed. This could be the surface plate as well, or the granite worktop, but there's some movement there. Let's start again. Right, so that's 35. Now it's become more consistent. He says, God, it's a good job I don't work in a testing department, wouldn't it? I think I'd last about 2 minutes before they kick me out. It seems consistent for that area, for that wide area. It seems fairly consistent to about 0.2 out. Which isn't, for the price tag, that's not too bad. I'm fairly happy with that. Now I'll flip it the other way around and test the actual rails itself. Themselves, should I say. Right, because I need to drag this, I thought of an idea to use a parallel across the two rails and indicate the parallel. So I tested this parallel first to see if this was consistent, and it's not. It's consistent on the top, how it's supposed to be used, the vice, so I know that that's going to be level as the rails anyway. But the actual face of it isn't. It's off by about 0.05 of a millimetre, something like that difference between the length. It dips in the middle and then raises at the end again. So what I've done is, because it's going to be dropping off the end, I don't want too much of a drop off, because when it gets to the next one it lifts it. You don't want to lift it too much, otherwise it throws inconsistencies. Now that's not touching at the moment, so I'll just drop it down. There's the wrong way mark, and I'll go say 0.1. 0.1, it's not 0.1, I'm thinking of a different indicator. Right, so I'll move it a little bit because this has got flex in the bar. Put that back to 0 at 1. Right, that's moved back again. Right, so that's point. Stop with your point mark. That's 11. That's 12. 11. 12. 11. There is flex in this. This isn't a fair. Gives an idea for the tools that most, or some anyway, some DIY weekend warrior hobbyists that have. Not going to have Kurt Weiss's top flight Mitutoyo indicators. This is a £10 thing off eBay. Right, well, I'm going to go the wrong way to indicate that way. Right, so point 1, I'll put pressure down on the bolt holes. That might give me a bit more of a even pressure. Right, that's gone to 11, 12, 10, 11. .11, 12. So what we're talking about is less than 0.01mm out across the rails, which I'm happy about, because the other vise that I've got, the vise that I'm used to, there's about 0.1 to 0.15mm difference between the actual rails, which is ridiculous. That's well out, so I'm happy with that. I haven't got a way to check the 90 degrees for the actual jaws, to check if they're 90 degrees to the actual rails themselves. So what I'm going to do is next I'm going to stick it on the mill and grip a piece of aluminium and see if there's any bruising along the aluminium. Because what happens is if you stick a piece of aluminium in there, squeeze it, if the top of the jaws are angled forward, you'll have like a bruise, like a cut mark, to look like a scribe mark across the block. If that's nice and consistent and both jaws are 90 degrees, then it'll compress it evenly. You won't have any bruise mark. So the next stage is stick it on the mill and do a proof of the pudding. Get a piece of steel in there and see if I can make it square. Right, real world measurements. Real world testing. So well and good measuring it on a surface plate where it's not bolted down. But the proof is obviously you're not going to be using a mill vise when it's not bolted down. So I bolted it down, made sure obviously the mill bed's clean. I've not squared it up, I've not trimmed the actual back jaw. Well, there is no back jaw on this, they're both movable. But I haven't levered it off because for this operation it's not needed. I learned this trick off Joe Piezinski. How to square up a block in the least possible steps. Just light a cigarette. Instead of like doing one face and then taking it out, putting it back in, hammering it, indicating it and everything, and then doing another face, all that issue. I'm going to go around all four sides. I've got this up as high as I dare. Go around all four sides, deck the top with a fly cutter, well, yeah, with a fly cutter for this side. Take the parallels out, put fresh parallels in, lower, get it low down, and then just basically mill the other side and deck the top. And then that should be square if everything's all good with this. Already I've noticed jaw lift on this quite badly. I've used a rubber mallet, tightened it up and used a rubber mallet to knock it down, and that's now tight. Can't move the parallels. So anyway, less talk, get on with it. I've already done this side, that was cut wonky. It was cut at a very bad angle. So I took most of it off already. Now I'm just going to go around, do light passes. Very light, because you haven't got much of a grip now. Just time a little bit. Right, now it's the jaw lift. See, there's no movement there. In fact, you're not even in view. There's no movement there. Tighten it down a little bit. Then move. These jaws not designed, obviously, because both movable. It's got a Dovedale. That's a town in England. It's got a dovetail design, which is fantastic. Minimises the lift up, but there's still quite a bit of lift up there. You know what I mean? So if you want a vice that actually pulls down, this is not the vice for you. But for the price point, £150, do you want to spend 4 or 5 times as much for a vice that pulls down? This size, I mean. You can get smaller vices that do pull down. It's the type with a M6 screw in it. You just screw it down and it pulls the actual front, the movable jaw, down by about 45 degrees, and it pulls the part down. Pulls the part down at the front but not at the back. It still raises at the back a little bit. So cheap rubber mallet, couple of taps, and it's nice and tight. We'll tap for good measure. And I can depth the top, not depth the top, sorry, mill it, because I need to mill quite a bit of that depth off, don't I, and then fly cut it. Right, this is the part that I've just machined. It's straight off, there's no stoning or anything like that. These sides here, that side and that side is the side that the jaws were compressing on. So I'll go across on the x-axis first. Right. Put that back to 0 to 40. See what I mean? It's not a very fair review, this isn't. It's that damn sensitive. Pretty consistent. Across to the other, close to the other jaw. This could be my machining as well. Just take it as an average. The average is pretty good. Now going y-axis. There is a bit of difference there. Although, is there? You're not doing it right with the indicator, are you? That way. Sorry, this way. God, I'm a flipping amateur. So I'm dragging the needle as opposed to pushing it. Pretty consistent. And the other side. Yeah, I'm happy with that for 150 quid. I'm not going to bother testing the actual side itself because that's how it's milled. That's all down to tram of the head as well. I suppose that will be as well because I fly cutted it. But obviously if the tram's out, the MO is going to be like that, isn't it? So you can't really test across that, and that's the machining. What you need, the most important test is obviously parallelism. When you stick a block in, you want to know that when you deck the top, it's going to be parallel between the top and the bottom face. That side is down to you, obviously, with your milling, the tramming of the head and the milling of it. So, as an amateur perspective, 150 quid with a little work. Obviously, they're not pulled down jaws. So you tighten it to the point where you need it, and then you just tap it down with a rubber mallet, and then job sorted. Job done. I've had been using it today. This is the first and only job that I've done with it to make this with the vise. It's the first and only job that I've done with it. I might make a follow-up video if there's any issues that arise from it. But I think that's that done.